Hello everybody, welcome to the section on regression lines and correlation coefficients. This is just an extension of our scatter plot section. So what you remember or should remember from the scatter plot section is how we talked about line of best fits and plotting data and then what kinds of correlation that we have. So whether it's positive, negative, or none. So what I want to go from there is talking about our regression lines. So regression lines are basically a more accurate line of best fit. So in the last video we talked about when you're finding a line of best fit, you pick 2 points on your data and you find a slope, and then you use those points and a slope and you come up with an equation of a line, and you do all those calculations yourself. Well, a regression line tends to be a little bit more accurate. What it does is it goes through this set of complex calculations. The computer does it or your calculator does it, and it creates an equation of a line that is as accurate as possible to fit as many of your data points as possible. So it tries to get all those data points really, really close to the line. Whereas if we do it by hand with just 2 random points, there might be some major outliers. All right. So you won't actually be calculating the regression lines, but you're going to be using technology to come up with those lines for your assignment. So correlation coefficients kind of go with that. A correlation coefficient is a number, because remember coefficients are numbers, and it's just a number that's between -1 and 1. All right, so it could be 1/2, it could be 0.8, 0.9, it could be -0.3, anything between -1 and 1. And we use the letter R as a representation for the correlation coefficient. So if you ever see R equals 0.5, you're probably talking about this particular correlation coefficient. And there's basically 3 scenarios that we're going to use for this correlation coefficient, and they are right here, so make sure you get those in your notes. The first one is if R is close to -1. So if it's -1 exactly, or if it's -0.98 or -0.9, what that means is that there is a negative correlation in your data. So remember, that means our data would be going downward in this kind of trend. If it's around 0 for your R value, then that means there's no correlation. So maybe your data is all over the place, it's scattered, it doesn't really have a pattern to it. Okay, and then if R is close to 1, so maybe 0.75, 0.95, something like that, then it's going to be a positive correlation. So that means that your data would be going upward and it would look somewhat linear. All right, so this is really important because this is going to tell you the type of trend that you have going on with your data, not just being able to look at the equation. Okay. So I'm going to take the information that was from the previous video. This was a data table about the year and then the average life expectancy for people in that given year. So go ahead and write your data down. And what I'm going to show you is how we can take that data and enter it into a calculator or a computer program, and we can make a scatter plot, and then we can use that program to find a regression line. And then once we have that regression line created, we can use it to predict life expectancy for other years. So for this example, we want to figure out the life expectancy for people in 2020, which obviously is not that far away. So what I'm going to show you to use, and for most of you, is going to be Desmos. So write this website down, www.desmos.com. Maybe some of you have used it before. Maybe some of you haven't. It's a graphing website. We're going to do some activities on there in this chapter and future chapters as well. So definitely bookmark this because we're going to use it a lot. I know some of you may have graphing calculators, and that is also awesome. You can use a graphing calculator for this, but most of you don't, so we'll go to Desmos most of the time. However, if you really do want to use your graphing calculator and you want to know how to work it, please come see me individually in class, and I will go through that with you on your own. So I'm going to show you how to do this in Desmos. I would suggest taking notes on the steps, and then obviously you're going to want to try this on your own computer and make sure that you're comfortable using it. So if you've got all that data written down, what we're going to do is go to desmos.com. Okay, so www.desmos.com, and you're going to go to the calculator. And what's going to happen is you're going to get a blank graph here. It's really nice. And there's a little plus sign up at the top, and this plus sign is going to give you some options. Most of the time it's just going to be a blank place here where you could type in equations like y equals 3x plus 2. and it will graph that line for you. Or you could pretty much graph anything, 3x squared, so that's a parabola. But obviously we're not graphing an equation, we're graphing a data table. So what I went ahead and did was I clicked that plus sign and I clicked on the table button, and this gives you your x's and your y's, and then all you have to do is just enter in your data. So I've already done that for us just to save us some time. So my X's were my years, and then my Y's were my life expectancy numbers. And then the problem is our graph is set at 0, 0 in the middle. So obviously these numbers are much larger than 0 to 8. So what you have to do is change your window. So to do that, you're going to click on the graph settings little wrench tool here. You're going to click on that, and you're going to look at what this tells us is that my window for my graph goes from -10 to +10. Well, my X values are from 1980 to 2006. So I need to have X values that fit this range. So I'm going to change my X value to 1970. Okay, and then my Y value, or my larger X value, I'm going to change it to 2015. So what I'm doing is just allowing my values, my X values, to fit this data. And then I have to do the same for the Y's. Well, the lowest Y value I have is 73.7. So maybe I make the Y value 65, and then maybe I make my largest Y value 82. Okay, and that's just going to allow us to fit our data a little bit better, so that way we can see our points. So if you notice, I've changed my data, and now I can see all of my data points plotted nice and neat on my graph. And then if you don't like where it's at, you can drag your grid around so you can see it a little bit better. All right, so there's my data. You could do this on your paper too and make a scatter plot, but this is already done for you. But this is just your data points. We want a regression line. So the way that Desmos does this is if we go ahead and type in an equation off to the left side, and when we do this, we have to make the equation in its slope-intercept form. So remember, that's y equals mx plus b. Okay, but the problem is we have to be able to get this data, this equation, to plug in these points. So what we're going to do is change it a little bit. We're going to type in y1. Okay, and if you just type in a 1, it will do that for you. And then that's going to refer to these y values. Notice that this says y1, so we're going to say those y values. And then instead of an equal sign, we're going to do this little symbol there on your calculator. And then the slope, so y equals m. And then instead of just x, we're going to use this column, so x1. So it's going to refer to these x values, and then plus b. So now what this did was this came up with a regression line that was going to use this data to get as close to all the points as possible. So notice that this orange line gets almost every single point exactly. So once we have this, if you look down in this box, it comes up with our R value. So notice R is 0.9911, and then it tells you what the slope is for the equation and what the y-intercept is. So all this does is give you the numbers to plug into your formula so that you have the equation of the line. So I'm going to drag this over here. Okay. So this says that our, let me shrink my screen. There we go. So this just told us that our slope was 0.11 or 144,102. So my equation would be y equals 0.144,102x, and then our b value was negative 211.432. Okay, and then just for good measure, we're going to write our correlation coefficient, which is R equals 0.9911. So remember that this correlation coefficient, it is close to 1. So what that means is that it is a positive correlation. I ran out of room. Okay, so positive correlation because it's really close to +1, which is a good thing. So that means our line is going upward. Okay, so now what we can do is we can use this equation right here, and we can plug in the year 2020, and we can see what the average life expectancy is. And because we know this is a positive correlation, what we should see is that more likely than not in 2020, our year is going to be going upward. So it should be bigger than 77.7. So we can go ahead and plug that in. So we'd have y equals our slope times the year 2020. and then minus 211.432. So you guys could plug this into your calculator and get that year, and then you would know roughly what the life expectancy would be for someone who was born in 2020. All right, so when you plot your data, go to Desmos, type it in, okay, and then remember to type this equation in here. That's going to get you a linear regression line, and then that's going to give you everything you need to know for your equation. So no calculations for you, Desmos does it for you. All right, so if you have any questions on how to use Desmos or how to type it in, or if you'd like to use your own graphing calculator, come see me and I will help you work through that. That's it for today. Thanks for listening.